Today we are going to look at the equation of a circle. Anytime that we draw anything at all, we can draw it in the coordinate plane. We could put a grid behind it and give it a coordinate grid. And anything that can be drawn in the coordinate plane needs to be able to have an equation. So the equation of a circle is going to look a little familiar to you in that it has h and k. Remember, h and k were the vertices or the vertex for our absolute values with the v's. It was the vertex for our parabolas when we studied quadratics. HK this time is going to be the center of our circle. So here's what it looks like. It looks kind of strange, but it's from the Pythagorean theorem is really where we get the equation from. So here we have x minus h squared plus y minus k squared equals the radius squared. So this just comes from leg squared plus leg squared equals hypotenuse squared, because these would be made into right triangles. That's why the radius squared would end up being our hypotenuse squared, and then these would be the lengths of the two legs. So HK is the center. You'll notice HK go here and here with the x and the y. The minus signs belong to the formulas. And then this r over here is simply your radius, but you're going to have to make sure to square that value. So here I just have a couple of equations for us to look at, and we're going to identify the center and the radius from each particular equation. All right, so x minus 2 squared plus y plus 3 squared equals 36. So the center is going to be our h and our k values. So as an ordered pair, the h is 2, the k, now pay attention, it is 3, but the formula is supposed to have a minus right here. So to get a minus to turn into a plus, we would have to plug in a negative, because then it would bam bam and turn into a plus. So 2, negative 3 is our center. And this down here, remember, is the radius squared. So the radius is not 36. The radius squared is 36. So if we square root that, we get 6. And we know it can't be negative 6, right? We know really that's plus or minus, but you can't have a negative radius. Let's look at the second example. Here we have 5 and 7. Pay attention to your signs. In order to get this to have turned into a plus sign, we had to have plugged in a negative, because minus a negative would bam bam. Our y value is a 7. That's again a plus, so we would have had to plug in a negative 7. The radius is the square root of 121, because the radius squared has to equal that, so the radius would be 11. The bottom one is a little bit tricky because you'll see here there's nothing with the x. So how have we shifted it? Well, the answer is we didn't. So if you don't shift something, that means you don't move it. So it has a 0 as its value. And then the y has changed with a k value of minus 4. It's supposed to be minus with the formula, so k is just 4. And the radius squared would be 10, so we would square root it. That's not a nice whole number, so we are simply going to say that the radius is the square root of 10. Now that does not break down or simplify in any way, shape, or form. Keep in mind we did that back in chapter 4. All right, now we're going to go work the other way around. We're going to be given the center and the radius, and we need to write the equation. So we'll start with x minus, and then we're going to plug in a minus 2. Well, when you plug in minus 2, what happens? Right, those bam, bam, so we really have x plus 2 squared plus y minus, and our k value is 10 squared, don't forget your squareds, equals, and then this is the radius, and remember we do the radius squared, so 3 squared is 9. So x plus 2 squared plus y minus 10 squared equals 9 would be our equation. And then we have a center of 1, 5, so x minus, and our h is 1 squared, plus y minus, our k is 5 squared, equals the radius squared, so 8 squared is 64, and there we would have our equation. Oftentimes when you see these on standardized testing, they will give you something more like this. You will not know the radius. We will have to calculate it. So we have the center at 3, 2, and we know it goes through the point 7,6. Well, we can start the equation because we know the center. So we could say x minus and then 3 squared plus y minus 2 squared equals. But we don't have a number to put here for r squared. So let me visualize that for you. Here's your center to your circle right here. And it goes through the circle, you know, up here somewhere in that direction. It's going to go through this point at 7,6. So the distance from the center to that point is going to be our radius. It has to be, because everything has to be equidistant from that center point. The question is, what is that? Well, if it's a diagonal length, we can't just count it. So instead, we can force that to become a right triangle, and we can do the Pythagorean theorem. So we would want to see how far has this changed and how far has this changed to be able to write those numbers. So this was an x value of 3, and this point had an x value of 7. So if I subtract those, 7 minus 3 gives me 4. So the x's have changed by 4. And then this distance had a y value of 2 at the center and a y value of 6 up here. So 6 minus 2 is 4. So this length is 4 and this length is 4. Now that doesn't always happen, but in this case they happen to be isosceles. So leg squared plus leg squared is equal to the hypotenuse squared. So 16 plus 16 is equal, oops, that's supposed to be an equal sign, is equal to radius squared. So 32 is equal to the radius squared. Now if I really wanted to find the radius, I could actually take the square root of that and get a decimal. But remember, in my formula over here, what's supposed to go right at the end is r squared. So r squared is 32. Okay, let's do that again without the picture, because I think that gets a little bit trickier. So we have x minus, and then we would plug in a negative 5 since this is the center. So negative 5 squared plus y minus 8 squared equals, and I know right here I want to put whatever r squared is. So we need to calculate what r squared is. Now, I don't know if you noticed what I was doing up here in this picture, but I was taking the first and second x values, so 7 minus 3, that's how I got this length of 4. So I want to do that down here. I want to take my second x minus my first x, so 1 minus negative 5. And that's going to give me 6. Okay, that's how I found my horizontal move. Now my y move, I ended up doing this higher number minus that lower number. And if I look over here, those were my second y's minus my first y. So let's do that. Talking about the vertical move this time. Okay. The second y is negative 3. And we're subtracting the first y, which was 8. And that gives me negative 11. So that tells me, that tells me this graph went down 11. It doesn't really matter that it went down, because if I'm thinking about a right triangle, then I know this shifted right 6 and down 11. There's my right angle. And I want to find that radius. So we'll need to take these two values and square them. So 6 squared plus 11 squared will equal the radius squared. 6 squared is 36. 11 squared is 121. That's going to equal the radius squared. We're going to add those together. So 157 is equal to the radius squared. Now again, I could take the square root and get the approximation for the radius, but I don't need to, because what I want to put in that box is r squared. And r squared right down here in our equation is 157. So we're going to put 157 right there, and there we have our equation then of x plus 5 squared plus y minus 8 squared equals 157. All right, how about writing the equation for the graphed circle? So the first thing we want to do is identify the center because we need that in our equation. So our center here is 1, 2, 3 to the right and 1 down. So 3, -1. And the radius, I don't have to do like I did up there on the others where those top equations from this, I was using points that were diagonal. I can actually count, but I have to count in the horizontal or the vertical fashion. So it's probably going to be easiest to count in the vertical or horizontal going upward. So I'm going to just go this direction. So 1, 2, 3, 4, and then looks like 5, maybe a little bit more. So you can approximate if you need to, because I'm not sure. Maybe 5, we'll say 5.5 or 5.5. If I went back this way, maybe because I don't know if that's right or not, 1, 2, 3, 4, 5, and you can see we had to go past a little bit there as well. So we'll call the radius 5.5. That's what you get for me having to do the drawings at home. I guess if I had a nice coordinate plane, I could have made my circles with nice radius, but we'll work with what we've got. So we have x minus 3 from the center squared plus y minus -1 from the center, so that's going to become +1 squared, equals, and then remember we need the radius squared. So since that wasn't a nice whole number, I can't just say 25. 5.5 squared, 30.25. And there we have the equation for our circle. The ones on the assignment aren't going to turn out funny like that. They're going to be a coordinate grid that you'll be able to see. One more example like that. All right, here we have our circle center. It's at 1, 2, 3 to the right, and then not up or down. So our center is 3, 0. And our radius, this one should be easier to count. I was trying for that. 1, 2, 3, 4. And that's just by going to the right, or you can go to the left. 1, 2, 3, 4. Hopefully up or down you would get the same values. So our equation is going to be x minus 3 squared plus, now normally I would want to do y minus something, but if I put in a 0 right here, a 0 doesn't change it at all, so I don't have to put -0, which means I don't even need the parentheses, and I can just say y squared equals, and then I want the radius squared, so 4 squared would be 16. So x minus 3 squared plus y squared equals 16 would be our final answer for our equation. As always, utilize your notes, utilize your equation. Feel free to look up anything else on the internet that would assist you, and then ask me any questions that you may have as you work through the assignment.